Imagine a normal morning in our solar system, the sun shining steadily, planets moving in their predictable paths, when suddenly, something invisible and terrifying appears. No explosion, no warning, no light. Just a region of space where gravity becomes so powerful that not even light can escape. What if black holes suddenly started appearing inside our solar system? This is not just a science fiction nightmare, it's a scenario that would challenge everything we know about gravity, space, and survival. Black holes are not cosmic vacuum cleaners that instantly swallow everything around them. They are extremely dense objects whose power comes from their gravity. If a small black hole suddenly formed somewhere between the planets, its danger would depend on its mass and location. At first, nothing might look different, but the gravitational balance that keeps our solar system stable would begin to change in subtle but deadly ways. The first signs of trouble would appear in the motion of planets and asteroids. Their orbits, which have remained stable for billions of years, would begin to shift. Scientists observing the skies would notice strange deviations, objects moving faster, slowing down, or drifting from their expected paths. Even a relatively small black hole could act like an invisible gravitational trap, pulling nearby objects into dangerous new trajectories. If a black hole appeared near the asteroid belt, chaos would quickly follow. Asteroids that were once safely contained could be flung outward or pulled inward toward the inner planets. Earth could face an increased risk of impacts as space debris begins to rain into new orbits. What was once a stable region of space would become a cosmic shooting gallery. The situation would become far more serious if a black hole appeared closer to Earth's orbital path. Our planet might not be swallowed immediately, but its orbit around the Sun could be distorted. Even a slight change in distance from the Sun could have dramatic consequences. Moving closer would trigger extreme global warming, while drifting farther away could plunge the planet into a deep and irreversible ice age. If a black hole passed near Earth itself, the gravitational effects would be catastrophic. The side of Earth closest to the black hole would feel a stronger pull than the far side, creating extreme tidal forces. These forces could stretch the planet's crust, triggering massive earthquakes, volcanic eruptions, and powerful ocean surges unlike anything in recorded history. One of the most terrifying possibilities would be a black hole capturing the Moon. If our Moon were pulled away or forced into a new orbit, Earth would lose its tidal stability and axial balance. This would destabilize our climate, disrupt ocean patterns, and create long-term environmental chaos that would threaten ecosystems and human civilization. The Sun itself would not be safe if a sufficiently massive black hole appeared nearby. If the Sun's motion were disturbed, the entire solar system could become unstable. Planets might shift into new orbits, collide with each other, or even be thrown into deep space. Our carefully ordered cosmic neighborhood could transform into a chaotic gravitational battlefield. If a black hole actually replaced or approached the Sun closely, the consequences would be immediate and devastating. Without the Sun's light and heat, Earth would freeze within weeks. Temperatures would drop, oceans would begin to ice over, and photosynthesis, the foundation of most life, would collapse. Darkness would become permanent. Yet black holes are not completely invisible. As they pull in gas, dust, or asteroids, the material heats up and emits intense radiation. If one began feeding within our solar system, scientists might detect powerful X-rays or unusual energy bursts. These signals could provide humanity with precious warning, though our ability to respond would be extremely limited. Space travel and satellites would also face enormous risks. Navigation systems rely on precise gravitational models, and a new massive object would disrupt everything from GPS to interplanetary missions. Space debris caught in unstable orbits could create a dangerous environment around Earth, threatening communication, weather monitoring, and global infrastructure. On a deeper level, the psychological impact on humanity would be profound. The idea that invisible cosmic objects could appear without warning and reshape our solar system would challenge our sense of safety in the universe. For the first time, people would truly feel.
However, this scenario also highlights the incredible precision of our current cosmic environment. The solar system remains stable because massive objects are rare and distances in space are enormous. The chances of a dangerous black hole appearing nearby are extremely small, reminding us that our existence depends on a delicate and fortunate cosmic balance. In the end, if black holes began appearing in our solar system, the greatest lesson would not just be about destruction, it would be about perspective. Our planet, our orbit, and our star are part of a finely tuned gravitational harmony. And in the vast, unpredictable universe, the quiet stability we experience today is not ordinary, it is extraordinary. If multiple black holes began appearing over time, the solar system would slowly transform from a predictable clockwork into a chaotic gravitational maze. Each new object would distort space around it, bending the paths of planets, comets, and dust in unpredictable ways. Long-term orbital calculations would become nearly impossible, and the future positions of celestial bodies, once known centuries in advance, would turn into uncertain estimates measured only years or even months ahead. Comets from the distant outer regions would be especially vulnerable to these disturbances. The Oort cloud, a vast reservoir of icy objects surrounding our solar system, could be shaken by the gravitational influence of passing black holes. This disturbance might send waves of comets toward the inner solar system, dramatically increasing the frequency of close passes and potential impacts with Earth and other planets. The night sky itself would begin to reveal strange and unsettling changes. Stars might appear to shift slightly from their normal positions due to gravitational lensing, a phenomenon where a black hole bends the light traveling past it. In some regions of the sky, stars could appear stretched, duplicated, or distorted, creating eerie visual effects that would signal the invisible presence of these massive objects. If a black hole drifted through the outer solar system, it could capture entire dwarf planets or moons into its orbit. Worlds like Pluto or distant icy bodies might be pulled away from the sun's influence and forced into new paths around the intruding object. Over time, the solar system could develop small, wandering gravitational systems nested within the larger one. The long-term survival of Earth would depend on distance and luck. Even if our planet avoided direct encounters, repeated gravitational disturbances could slowly alter its orbit over centuries. Climate stability relies on consistent solar energy, and even gradual changes in Earth's distance from the sun could shift weather patterns, sea levels, and global ecosystems in ways that challenge human adaptation. Humanity might attempt to respond with advanced space monitoring and early warning systems, scanning for gravitational anomalies and radiation signatures. Scientists would likely develop new models of planetary defense, not against asteroids alone, but against large-scale orbital disruptions. While we could not move a black hole, early detection might help prepare Earth for climate shifts or increased impact risks. In the end, a solar system filled with unexpected black holes would remind us of a powerful truth about the universe. Stability is not permanent. It is the result of balance, distance, and cosmic luck. Our current celestial neighborhood is calm, orderly, and life-supporting not by accident alone, but by a rare combination of conditions. And if that balance were ever disturbed, humanity's greatest challenge would not just be survival, but learning how to live in